Ever asked a machine a question and gotten a surprisingly human answer? It's a moment that can feel almost magical. Like the future has arrived right at your fingertips. Maybe an AI chatbot fixed your code, wrote a poem about your cat, or even helped you brainstorm ideas for a project. These digital assistants are becoming part of our daily routines, often in ways we barely notice. This isn't science fiction, it's happening now, everywhere. On our phones, laptops, and in our homes, AI is quietly transforming how we live, work, and connect with each other. AI models like ChatGPT are now personal tutors, creative collaborators, and tireless assistants. They help us draft documents, plan trips, compose music, and even learn new skills, adapting to our needs in real time. The speed of this change is staggering, leaving us both amazed and a bit confused. It can feel like technology is evolving faster than we can keep up. But how does it actually work? How does a machine understand and generate language that feels so human, so natural, and sometimes even witty? Today we'll pull back the curtain and take a simple, step-by-step journey into the heart of AI's digital mind. We'll explore the fascinating process that lets machines mimic the way we think and communicate. By the end, you'll see that this ghost in the machine is really just brilliant engineering and a mountain of data working together to mimic human language, demystifying the technology shaping our world. At the core of systems like ChatGPT is a large language model, or LLM. These are advanced artificial intelligence systems designed to process and generate human language in a way that feels natural and intuitive. These models are trained on massive amounts of text, books, articles, websites, learning to predict the next word in a sequence. By analyzing countless examples, they develop a statistical sense of how language works, picking up on grammar, style, and even subtle nuances. Think of it as predictive text on your phone, but scaled up to billions of examples and parameters. Instead of just finishing your sentences, it can write essays, answer questions, or even create poetry, all by predicting what comes next. The large part refers to both the size of the model and the data it's trained on, billions of digital knobs, fine-tuned to spot patterns in language. These parameters allow the model to capture the complexity and richness of human communication. LLMs don't think or understand like humans, they're complex pattern matchers, not conscious beings. They don't have awareness or intentions, but they can mimic understanding by recognizing and reproducing patterns in data. Imagine a librarian who's read every book in the world and can guess what comes next in any sentence. This librarian doesn't truly understand the stories, but is incredibly skilled at predicting what words are likely to appear. The LLM is like that, but for nearly all the text on the internet, with its intuition encoded in math. It uses complex algorithms to turn language into numbers and patterns, making sense of vast amounts of information. It doesn't have beliefs or feelings. It's a master of probability and association. Every response is calculated, not felt, based on the likelihood of words and phrases fitting together. Its power comes from recognizing patterns and relationships in language, not from understanding the world. It excels at connecting ideas, drawing on its vast training data to generate relevant and convincing text. This is what lets it generate text that feels coherent, relevant, and even creative. The result is language that can inform, entertain, and assist, all powered by the patterns it has learned. But how does a machine, which only understands numbers, process human language? The first step is tokenization, breaking text into smaller pieces called tokens, which might be words, parts of words, or punctuation. Each token is assigned a unique number, turning sentences into sequences of numbers the AI can work with. This translation is crucial. It standardizes all text, whether it's poetry or a technical manual, into a format the AI can process. But a list of numbers isn't enough. The number for powerful doesn't tell the AI it's similar to strong. The model needs a way to capture relationships and context between words. That's where the next step comes in, turning these numbers into rich, meaningful representations. This is what gives the AI its apparent understanding of language. After assigning numbers to tokens, the AI transforms them into vectors, long lists of numbers called embeddings. Think of each word as a point in a vast, multi-dimensional space, where similar words are close together and opposites are far apart. The AI learns this galaxy of meaning by analyzing trillions of sentences, placing related words near each other. This lets the model understand analogies and relationships like king minus man plus woman equals queen. Embeddings allow the AI to reason about language, not just memorize it. When you type a sentence, the AI tokenizes it, looks up each embedding, and now has a rich mathematical map of your words. This high-dimensional representation is packed with context and meaning. It's the raw material the AI uses to generate responses. Now, the stage is set for the AI's main event, processing these embeddings to create an answer. Now the sentence, represented as embeddings, enters the brain of the operation, the transformer. This is where the real magic of language understanding begins, as the model starts to process and interpret the information it receives. The transformer's key innovation is the attention mechanism, which lets the model focus on the most important words in a sentence, no matter where they are. Instead of reading words one by one, it can look at the whole sentence at once, weighing the relevance of each word to every other word. For example, in the delivery truck, which was carrying fragile vases, dropped its cargo, attention helps the AI link its to vases. This ability to connect distant words is crucial for understanding complex sentences and resolving ambiguity. Multiple attention layers analyze different relationships, grammar, meaning, context, building a deep understanding of the text. Each layer uncovers new patterns, allowing the model to interpret subtle nuances and hidden meanings. It's like a team of experts, each focusing on a different aspect, combining their insights. Together, they create a richer, more complete picture of what the sentence truly means. After processing, the model predicts the next word, adds it to the sequence, and repeats the process. This step-by-step generation ensures that each new word fits naturally with the context that came before. This loop continues word by word until a complete answer is generated. The process is fast, efficient, and can handle even long, complex prompts with ease. The result? Text that feels natural, relevant, and tailored to your prompt. It's as if you're having a conversation with someone who truly understands what you're asking. The transformer's attention is what makes modern AI so powerful at language. It's the secret ingredient that allows machines to read, write, and communicate with remarkable fluency. It's the engine behind the magic, driving the breakthroughs that are transforming how we interact with technology every day. The real impact of large language models is seen in their everyday applications. In software development, AI assistants generate code, spot bugs, and explain complex concepts, making programming faster and more accessible. In medicine, LLMs help doctors diagnose rare diseases, summarize patient notes, and draft clear communications. Education is being transformed. Students get instant feedback, personalized explanations, and language practice, while teachers automate grading and lesson planning. Legal professionals use AI to summarize case law. Marketers generate ad copy. Scientists analyze research at scale. The core skill, understanding and generating text, applies to any field that relies on information. We're just scratching the surface of what's possible. This technology is unlocking new ways to learn, work, and create. We're at a turning point, like the invention of the printing press or the internet. Large language models are changing how we interact with information and machines. Soon AIs will understand not just text but images, audio, and video, opening up new possibilities. But with great power comes responsibility. We must address bias, misuse, and the impact on jobs. Thoughtful regulation and ethical design are essential. Understanding how these systems work is the first step to using them wisely. The real question now isn't just how does it work, but what will we do with it? The story of this new era is unwritten, and you can help shape it.